Hello everybody, welcome. We are going to spend a little time delving into ChemQuest number 6. So you guys have been given this during class, right? This video will serve as an explanation of kind of the reasoning through the first 9 critical thinking questions that you have been collaboratively talking with your table groups about and your teacher. All right, so let's delve in. So the first 4 questions, right? What we're doing is we are examining a model of hydrogen, different types of hydrogen atoms, right? So we see that little symbol H, right? And that is an indicator that we are looking at models of hydrogen atoms. And in this case, our little key here shows that we have protons, electrons, and neutrons in those atoms of hydrogen. Okay, so what we want to be able to do is relate these symbols, right, and their numbers, right, to a sort of a model of the atom, but also to numbers of protons, electrons, and neutrons. Okay, so in this case, we're just going to simply look at our symbol, compare it to the model, right, and come up with numbers. So for example, it says how many protons are found in each of the following: hydrogen 1,1, 2,1, and 3,1. Now, in each of those cases, if we go over here and look at our model, we have 1 proton, 1 proton, 1 proton. So the number of protons is 1. Right, so there's 1 proton in all 3 varieties of hydrogen. Okay, now if we come down here and look at neutrons, okay, in the first model, hydrogen 1, 1, right, we have 1 proton. So this one has 0 neutrons. Hydrogen 2, 1 has 1 proton, 1 neutron. And hydrogen 3, 1 has 2 neutrons. Okay, so one thing we should begin to notice right away is that the number of protons in all varieties of hydrogen is 1. So all hydrogen varieties have 1 proton. Okay? However, different varieties of hydrogen atoms have 0, 1, or 2 neutrons. So an inference we can make is the number of protons in a certain element does not change, but the number of neutrons in an atom of an element can change. All right. Now, if we look at number 3, it says how many electrons are found in each of the following. Okay. In this case, we have 1 electron, 1 electron, 1 electron. So all 3 varieties have 1 electron. Okay. So we're going to circle this word atoms. All right, and we did talk about in class how atoms infer a neutral charge, right? So that is important. So I'm going to go ahead and just make a little note. Atoms, when we use that word, are always neutral, which means they don't have a +1 or a -1 or a +2 or -2 written in that symbol, if we're using the word atom. If there is a plus or a minus, we use the term ion, and we'll get to that later. Okay, but all hydrogen atoms have 1 proton and 1 electron. All hydrogen atoms, atoms being neutral, have 1 proton, 1 electron. And as we talked about in class, it is that number of protons. It determines what symbol that is, what type of element it is. Now, let's move on. Let's take a look now up at models of different varieties of carbon atoms. All right, so if we examine the model of hydrogen, we have different mass numbers. So we have mass number of 12, a mass number of 13, and a mass number of 14, right? In all carbon atoms, right? If we go and compare these 3 models of carbon atoms, and again, atoms being neutral or having no plus or minus charge, right? All carbon atoms, if you look at the models, have 6 protons and 6 electrons. Okay? And again, being that number of protons tells us that it is in fact carbon, right? 6 protons, 6 protons, 6 protons. And so one thing I do want you guys to remember is if it does not have 6 protons, that means it is not carbon. It is something else. Okay? So now let's take a look at the mass number. So in each of these cases, right, I'm going to erase a little bit so we can see. Okay? In each of these cases, right, we have 6 protons, and we learned in the PhET simulation, right, that each proton is a +1 in mass, right? So the total mass for carbon-12, right, comes from the combination of 6 protons and 6 neutrons. All right, carbon-13 has 6 protons and 7 neutrons. 6 plus 7 equals 13. Here, 6 plus 6 equals 12. And here, 6 plus 8 equals 14. All right? So the mass number tells us the number of protons plus the number of neutrons. Okay? Now, I want you guys to notice that the mass, right, is not accounting for the number of electrons. And the reason for that will come up on the next section. Okay? So mass number is the number of protons plus the number of neutrons. Okay? The atomic number, that bottom number, is just the number, whoops, again, the atomic number is just the number of protons only, right? So the atomic number, that little bottom number that we see down here, so that's 6, right, that we see for carbon, or the 1 that we saw for hydrogen, that tells you how many protons there are. And remember, the number of protons tells you the name of the element, or what type of element it is. Okay? But there's different varieties of atoms, and we're going to give those varieties a name here in just a minute. They're the same type of atom, right? They have the same number of protons, but they can vary in the number of neutrons. All right. Let's move on. So now, what we want to do is we are going to build a definition for the term isotope, right? So I want you guys to pay close attention, right? I am going to use this term isotope a lot, right, in several units throughout the year. So we need to know what this means, right? Isotopes are, one way we could think of it is different varieties of same type of atom, right? So, and remember, atoms do not have a charge, all right? So, what does that mean? So, if we have different varieties of the same type of atom, that means, right, same number of protons, okay, but different mass numbers. So, same number of protons means it's the same type of atom, right? But we can get different mass numbers, right? And then how that happens, so it says, how does one isotope of carbon differ from another isotope of carbon, right? So here's one isotope. One isotope has 6 protons, 6 neutrons. Another isotope has 6 protons, 7 neutrons. And then we have 6 protons and 8 neutrons. All 3 isotopes have 6 protons. All 3 isotopes have 6 electrons. So what does differ is the number of neutrons.